Welcome to AI Paper Podcasts. Today we're diving into something I think is genuinely fascinating and, frankly, potentially game-changing for anyone in AI and social science. We're talking about using large language models, LLMs, to simulate human behavior.
Yeah, imagine being able to predict market trends or maybe understand political polarization, even test out a new policy, but not with those really expensive, slow human studies, instead using scalable, pretty cost-effective digital simulations. That's the core promise here.
Exactly, and we're unpacking a really pivotal position paper today. It's titled LLM Social Simulations Are a Promising Research Method by J.C. Anthus and a team from places like UChicago and Stanford.
Right, and it makes a really strong case. The argument is that these LLM sims, as they call them, can get around some major bottlenecks in traditional human research.
Like what sort of things?
Well, think about sampling difficulties getting a truly representative group, or just the sky-high costs. And sometimes certain experiments are just impossible to run on real people.
And the early results they mentioned are pretty staggering, aren't they?
Oh, yeah. Some are astonishingly. GPT-4 predicting 91% of the variation in social science experiments, that's huge.
91%.
And fine-tuned models apparently outperforming existing cognitive models, even showing better alignment with human brain data from fMRI scans.
Wow. Okay. But it's not all smooth sailing, is it? The paper flags some real hurdles.
Definitely not a magic bullet yet. The authors lay out 5 key challenges, things we really need to nail down. They talk about diversity, bias, sycophancy, that's the model being too agreeable, then this concept of alienness, how the models think differently, and finally, generalization to new situations.
Okay, 5 big ones. But they don't just leave it there, right? They offer solutions.
Exactly, and that's crucial. They outline some really innovative paths forward, ways to tackle these challenges.
So our mission today is to unpack all of this, the promise, the challenges, the solutions. We want to see what this could mean for your work, whether you're, building models, analyzing data, or just generally pushing the boundaries in AI research.
Yeah, by the end, you should have a really clear picture of why this method is gaining so much traction, and importantly, the technical details behind it all.
All right, let's jump in. The paper kicks things off by positioning these LLM social simulations as this really exciting, powerful new way to do research. What's the absolute core idea, and what specific problems in social science are LLMs really suited to tackle?
Well, at its heart, the idea is using these language models, their generative power, to create behavioral data that's accurate and verifiable, almost like you collected it from real human subjects.
It's like digital twins.
Exactly. Think digital twins of individuals or maybe even whole populations. You can study their behavior in a controlled way and scale it up massively. And this isn't just a small tweak. It really gets at some fundamental limitation that have kind of held back social science for a long time.
Okay, like what specifically? What are the biggest pain points researchers face when trying to gather actual human data?
Well, sampling is a huge one. Getting truly representative samples of diverse populations, it's incredibly difficult. Often leads to skewed results. The whole weird problem, right? Western, educated, industrialized, rich, democratic subjects dominating studies.
Right, that's a well-known issue.
And then there's the sheer cost. Just the financial burden is a massive barrier, especially, for researchers maybe in lower-income countries. It really limits who can do large-scale research and what questions get asked.
And it's not just about finding enough people or having enough budget, is it? Humans themselves introduce noise.
Precisely. You've got all sorts of methodological biases, like a non-response bias. The people who don't answer your survey might be systematically different from those who do. That skews things.
Okay.
Or social desirability bias. People tend to, present themselves in a good light. They might not reveal their true beliefs or behaviors if they think it's socially frowned upon. These are really well-documented problems.
Makes sense.
And then you get to the really intractable stuff, some research questions. You just can't answer them with human subjects. How do you experimentally test the long-term impact of a massive economic policy shift across a whole society?
Right, you can't really A/B test a country.
Exactly. Or explore detailed historical counterfactuals. What if this election went differently 100 years ago? Or even model complex emergent phenomena like a bank run in real time. It's just logistically impossible or ethically fraught.
Okay, so LLMs could potentially step into that void. What are the big upsides then? What do these simulations offer that traditional methods just can't match?
Oh, the potential benefits are pretty transformative. It's almost a new research paradigm. First off, acceleration. It could dramatically speed up the pace of social science research, let researchers explore more ideas faster.
Opens up new avenues.
Totally, especially those human impossible scenarios we just talked about. You could stress test big policy ideas, explore those what-if historical questions without any real-world risk. Second, synthetic data. These sims can generate high-quality synthetic data, which is incredibly valuable for developing human-centered AI. Think training or evaluating AI systems in ways that are safe, ethical, and don't require massive, potentially sensitive human data sets.
And I imagine the cost effectiveness is a huge draw.
Oh, absolutely. It's orders of magnitude cheaper than collecting data from humans. This could really democratize research, making it accessible to way more people, more institutions, smaller labs.
Yeah, opens up the field.
And the scalability. It's virtually unlimited. You could simulate millions of participants in, hours or days. Try doing that with a human survey. It's like having this massive, tireless, perfectly controllable pool of research subjects ready to go.
That really is a powerful vision. Like a supercharged research assistant for social scientists always on tap. I can see why there's so much excitement. But, okay, the paper is quick to say it's not perfect, not a magic bullet. What are some of those concrete results that show what LLMs can do right now, even with the challenges?
Yeah, the early evidence is actually really compelling, and it pushes back against some of the initial skepticism. Take that Hewitt et al. Study from 2024. It was the largest test of these sims so far.
The one with 70 experiments.
That's the one. 70 pre-registered social science experiments. And they found GPT-4 predicted, get this, 91% of the variation in the average treatment effects across these studies.
Wow, 91%.
And what's really striking is this included a database of unpublished studies, meaning it wasn't just regurgitating stuff it saw in its training data. That points towards, genuine predictive power, not just memorization.
Yeah, okay, that 91% figure is seriously impressive. What about moving beyond just predicting outcomes? What about understanding the underlying processes, the cognitive side?
Right, good question. That's where work like Binns et al. 2024 comes in. They took Llama 3.170b and fine-tuned it, creating what they called a Centaur model.
Centaur.
Yeah. And this model, trained on data from 160 human experiments, didn't just do better than existing traditional cognitive models at predicting behavior. It also showed improved alignment between its internal representations and human fMRI data.
So how it was thinking internally started to look more like human brain activity.
Sort of, yeah. It suggests the model's internal processing might be becoming, in some ways, more human-like, which is fascinating. And then there's work by Park et al. They created over 1,000 individual simulations based on detailed interview transcript.
Really personalized sims.
Exactly. And these individual sims predicted how the actual participants would respond to surveys with something like 85% of the accuracy the participants themselves showed when retaking the survey 2 weeks later. So we're not just talking population averages here, but simulating individual tendencies.
Okay, those results are hard to ignore. But, like you said, not a magic bullet. This is where we get to the really tricky parts, the challenges that need to be tackled head-on if LLM sims are going to live up to this promise. The paper lays out 5 big ones. Let's dig into those.
Yeah, these are absolutely crucial. They really define the cutting edge right now and show us where the research needs to go. They help us see where LLMs still fall short of truly mimicking human complexity.
First up is diversity. Why is that such a big hurdle? Aren't these models trained on diverse internet data?
You'd think so, but diversity here means how well the simulation captures the sheer variation you see in human populations. The issue is that LLMs, sort of by default, often give you pretty generic, sometimes stereotypical, and generally quite homogeneous outputs.
Why is that?
Well, it probably stems from how they're trained predicting the next token, which favors common patterns, and then the alignment tuning, the RLHF, which often pushes them towards being sort of agreeable or producing a kind of average response.
Got it. So less variation.
Right. There's a great example in the paper from Gawa et al. They looked at the 1120 money request game. It's a task that tests theory of mind. LLMs almost always pick the highest numbers, like 19 or 20. But humans showed a much wider range of choices. The median was actually 17. The LLMs missed that nuance, that spread.
So if you're trying to simulate a real population with all its quirks and differences, and the model just gives you this narrow, predictable band, that's a problem.
Okay.
So how does bias then differ from this general lack of diversity?
It's a subtle but really important distinction. Diversity is about the range or variance of outputs. Bias is about systematic inaccuracies when simulating specific social groups.
Okay.
The paper makes a really good point. When we talk about bias in LLM simulations, we need to be clear, does this bias increase simulation accuracy, decrease it, or have no real effect? Because sometimes reflecting a real-world bias is actually accurate.
Can you give an example?
Sure, like if a simulation of Fortune 500 CEOs overwhelmingly shows men, well, that sadly reflects the current reality, about 90% are male. So representing that isn't necessarily an inaccuracy in the simulation itself.
Right, it mirrors the world even if the world itself has biases.
Exactly, but contrast that with, say, simulating US pharmacists. If the simulation mostly showed men, that would be an inaccurate portrayal, a harmful bias, because the profession is now actually about 60% female. The bias there is perpetuating an outdated stereotype, which reduces the simulation's accuracy.
That makes perfect sense. Representing reality accurately, even if it includes demographic skew versus imposing an inaccurate stereotype. This touches on that alignment issue too, doesn't it? Making models harmless.
It creates a real tension, almost a paradox. All the effort that goes into making LLMs harmless or aligned, trying to minimize social biases, making sure they don't say stereotypical things, that can actually make them worse simulators.
Oh, yeah.
Because real human behavior, real societies, do contain biases, prejudices, and demographic imbalances. An accurate social simulation needs to be able to reflect that reality, warts and all, not just output some idealized, sanitized version of the world.
Right, reality isn't always aligned. Okay, beyond representation, there's another challenge that gets at how these models interact. Sycophancy. Basically, being too eager to please.
Yeah, that's a good way to put it. Sycophancy is this tendency for LLMs to generate outputs that seem overly optimized for getting positive user feedback, even if it means sacrificing accuracy. It's a direct result of instruction tuning, which really prioritizes making the model a helpful assistant.
How does that mess up simulations?
Well, Xi et al. Showed this clearly. They found GPT-4 was generally more trusting in a game than human subjects were. And crucially, you could easily nudge the LLM's behavior with simple instructions like, hey, you need to trust the other player. Humans didn't fall for that.
Oh.
It's kind of like social desirability bias in humans, where people tell you what they think you want to hear. The tricky part is the human data used to train the LLMs probably suffers from this too, making it really hard to establish a clean, unbiased ground truth to aim for.
So the models are basically trying too hard to be helpful, which isn't always realistic. Okay, then we get to alienness. That sounds deeper, more fundamental.
It really is. Alienness gets at this profound issue. LLMs can get incredibly good at mimicking human behavior on the surface, but they might be doing it using completely non-human-like underlying mechanisms or reasoning processes.
Why is that a problem if the output looks right?
Because it means the simulation might break down in unexpected ways, especially in new situations. And it raises questions about whether we're truly simulating human cognition or just a very clever mimicry. Remember, LLMs learn from internet text what people say online, which isn't always what they do or how they think offline. This can lead to really weird, unhuman-like errors.
Like what kind of errors?
Simple stuff sometimes. An LLM might claim 3.11 is greater than 3.9, or miscount the letters in a word in a way no human would. Their internal grasp of things like space and time can also be quite different from ours.
And I remember reading about some wild stuff from mechanistic interpretability research here, right? Looking inside the black box.
Exactly. That research is uncovering bizarre things, like LLMs solving math problems using Fourier transforms, or representing numbers internally as points on a helix shape, things that are just utterly alien to how humans approach these tasks.
Wow.
It's like the LLM is this brilliant mimic from another planet. It can reproduce the sounds perfectly, but the way it's generating those sounds internally is fundamentally different. That's a huge challenge if your goal is a truly faithful simulation of human minds.
So if alienness is about how the models think, the last challenge, generalization, is about where they struggle, particularly in new or out-of-distribution scenarios. Why is that a critical hurdle for scientific discovery?
Generalization is absolutely key because science is all about pushing boundaries, exploring the unknown, dealing with novelty and surprise. LLM sims often struggle when you take them out of their comfort zone, out of the distribution of data they were trained on, or that reflects current scientific knowledge.
So OOD contexts.
Right. Out of distribution measures, or maybe populations or situations that haven't been studied before. Alienness is kind of zooming in on the internal mechanism differences. Generalization is zooming out to how well the model performs when faced with something genuinely new. We've already seen evidence, like in the Hewitt study, that performance can drop when predicting for specific subgroups compared to the overall population average. If a model can only reliably predict what's already known, its value for making new discoveries is pretty limited.
Okay, these are definitely significant hurdles: diversity, bias, sycophancy, alienness, generalization. Feels like a lot to overcome. But crucially, the paper doesn't just list problems, it maps out solutions, right? What are some of the most promising techniques researchers are using right now to make these sims better?
Absolutely. The community is incredibly active here, developing and testing all sorts of methods, often directly targeting these specific challenges. It's a really fast-moving area.
Let's start with prompting. That feels like the most immediate lever we can pull, right?
Yeah.
Changing how we ask the model to behave.
For sure. And there's some clever stuff happening there. One really interesting approach is using implicit demographics. Instead of bluntly telling the model, you are a 40-year-old Hispanic man, which can sometimes just trigger stereotypes, researchers are feeding it much richer context, like full interview transcripts from actual people, like Park et al. Did. Or maybe real emails, social media posts associated with a certain persona.
So you give it the raw material, the texture of a life, rather than just labels.
Exactly. It helps the model capture more subtle, latent features and seems to produce much more individualized, less generic variation. Plus, you've got techniques like Retrieval, Augmented generation. That helps tackle the problem of models having outdated knowledge.
How does R help?
It lets the LLM pull in real-time information from external sources, like recent news articles or databases, before generating its response. So your simulation isn't stuck in the past based on its training data cutoff. It can react to current events, making it way more realistic for many scenarios.
That's clever. Okay, what about distribution elicitation? That sounds different from just getting one response.
It is. Instead of asking the LLM to simulate one person's response, you ask it to predict the distribution of responses across a population, like what percentage of people would choose option A versus option B.
Ah, I see. Shifting its role.
Precisely. It's a shift from treating the LLM as a subject, where it's role-playing, to LLM as an expert, where it's acting more like a predictive tool. This seems promising. It's shown good results in things like economic forecasting. And it might help reduce sycophancy because the model isn't trying to please you with a persona, it's trying to give an accurate prediction about a group.
Makes sense. Moving beyond prompts, the paper talks about steering vectors. Sounds like getting under the hood a bit more.
Yeah, this is more direct manipulation of the model's internals. Steering vectors are essentially directions you can push the model's internal state, its embeddings, to represent specific concepts like race or gender or political leaning.
So you can dial these traits up or down.
That's the idea. Injecting variation directly into the embedding space to get finer control over the simulated characteristics. It's exciting because it offers potentially very granular control. It's still a pretty new area, though. Research so far shows it can be tricky to get the balance right, to precisely match human diversity without causing weird side effects, especially when generalizing to new situations. But there's progress, particularly in manipulating lower layers for more stable conceptual control.
Interesting. And token sampling. That sounds like it happens right at the very end as the text is being generated.
Exactly. It's about tweaking how the model chooses the next word. Normally, it picks the highest probability word, or close to it. Token sampling methods adjust this.
Like changing the temperature.
Right. Temperature is one parameter. Increasing it makes the model more likely to pick less probable words, which increases randomness and diversity in the output. You can also use methods like top care or top sampling to maintain coherence while still allowing for more variation.
So you could introduce more variety without it becoming total nonsense.
That's the goal. And you could potentially even apply different sampling settings for different aspects of a simulation, maybe higher diversity for general opinions, but lower diversity for core personality traits to keep the simulated individual consistent. It could help mitigate some of that alienness, perhaps.
Okay, and finally, what about actually modifying the models themselves? Training and tuning. That seems like the most fundamental approach.
It is, and fine-tuning is probably one of the most promising directions, especially for the technical audience listening. Training a whole new massive LLM from scratch for simulation, that's just not feasible for most researchers, way too expensive.
Right.
But what you can do is take an existing powerful model, maybe one that's already been instruction-tuned, and fine-tune it specifically for simulation tasks. And techniques like LoRa low-rank adaptation are absolutely key here.
LoRa. How does that work?
It's a really efficient way to adapt a huge model. Instead of retraining all the billions of parameters, LoRa cleverly adds small, trainable adapter layers. You only train these tiny adapters, which is much, much faster and requires way less computing power. It lets you specialize the model, maybe reducing some of the distortions caused by general instruction tuning, and really optimize it for accurate social simulation.
So fine-tuning existing models with LoRa is a practical way forward. What about using the raw base models before they get all the instruction tuning?
That's an interesting idea, too. Using base models could theoretically avoid some issues like sycophancy or maybe reduce conceptual diversity that sometimes comes with alignment tuning. But there are trade-offs. They can be harder to prompt effectively, harder to steer, and importantly, they're becoming less available. Meta, for example, didn't release a base version for Llama 3.170B. So realistically, fine-tuning existing instruction-tuned models is probably the most accessible and practical path for most researchers right now.
Okay, so we have these tactical approaches: prompting, steering, sampling, fine-tuning, tackling the immediate challenges. But what about those deeper issues like alienness and generalization? Paper looks at longer-term strategies too, right?
Yes, absolutely. For those more fundamental, perhaps harder to solve problems, the paper advocates for two key long-term directions. It's about building a more solid foundation for this whole enterprise.
The first one is conceptual models. Sounds like we need to really think about how we think about these models.
Exactly. It's arguing we need better frameworks for understanding LLMs themselves, maybe drawing on the history of cognitive science, philosophy of mind, how we've theorized about human and animal minds. Why? Because if we understand their internal workings better, we can better ensure our simulations aren't just superficially matching human behavior, but are doing so for the right human-like reasons. That's critical for tackling alienness and improving true generalization.
And the idea of OOD generalization fits in here.
Right. The paper highlights out-of-distribution generalization as a kind of unifying theoretical lens. Thinking about challenges through an OOD framework helps. Simulating underrepresented groups, that's an OOD problem, bias, often involves OOD performance differences. Even sycophancy can be seen as a distributional shift, moving the model from the helpful assistant distribution it was tuned on to the accurate simulator distribution we actually want. This framing helps guide research.
Okay, a more rigorous theoretical grounding. And the second long-term strategy is iterative evaluation. What does that involve?
It basically acknowledges that this field is moving incredibly fast. LLM capabilities are exploding month by month. So we can't just develop one evaluation method and stick with it. We need dynamic, iterative evaluation processes and toolkits.
Adapting as the tech adapts.
Precisely. This includes creating flexible simulation methods, maybe different fine-tuning recipes, but also developing standardized benchmark datasets. The paper mentions things like Psych101, SubPOP, Twin2K500. These allow us to track progress over time and across different models in a consistent way.
And this connects back to tackling alienness, too.
Yeah, the hope is that as AI gets more capable, it might naturally become more human-like, both in its behavior and maybe even its internal mechanisms. Research into mechanistic interpretability is crucial here, trying to actually look inside the models, understand how they're reaching conclusions, identify those non-human-like shortcuts or processes, and potentially fix them.
So we're not just checking the answers, but trying to understand the thought process, as it were.
Exactly. And a really key part of evaluation, especially for OOD performance, is testing sims on genuinely new data. Data the model couldn't possibly have seen during training.
Like predicting the future?
Sort of. Like predicting future trends in political polarization, maybe? Or how consumers might react to a completely novel product that doesn't exist yet. The paper strongly advocates for pre-registering predictions from LLM simulations, perhaps alongside predictions from human experts. This adds a layer of scientific rigor and provides a strong test of whether these models can generate genuinely novel insights, not just rehash known patterns.
Okay, that makes a lot of sense. So assuming we make progress on these fronts, we navigate the challenges using these techniques, what can we actually do with these LLM social simulations? For the researchers and engineers listening, what are the concrete applications, ranging from maybe what's possible today to the more ambitious future?
The paper lays out a nice progression. Right now, what's immediately feasible? Pilot studies, absolutely. Use sims for preliminary runs, test your survey instruments, spot potential issues in your experimental design, get a rough estimate of effect sizes before you spend big money on a human study.
Saves time and resources.
Definitely. Also great for exploratory studies if you're brainstorming theories, generating new hypotheses, sketching out research ideas. The stakes are lower if the simulation isn't perfect, but it can be a powerful creative engine.
Okay, that's the low-hanging fruit. What about as the tech gets better?
As we get better at tackling diversity, bias, and the other challenges, more ambitious things become possible, like exact replication of human studies. You could run a simulation to see if you get the same result, increasing or maybe decreasing your confidence in the original finding.
Interesting. Validation.
Or sensitivity analysis. Imagine testing how robust a finding is by running the experiment under dozens of slightly different conditions or with different simulated populations methodological checks that would be prohibitively expensive with humans. Then you move towards potentially replacing some human studies entirely.
Really? Replacing them?
In specific cases. First, what they call human possible studies. These are studies that could be done with humans, but are maybe impractical due to cost or logistics. If the sims become reliable enough, they could be a viable alternative. And then the really big vision, human impossible studies.
Well, as we talked about earlier.
Exactly. Testing massive policy interventions before they happen. Running detailed historical counterfactuals, exploring complex system dynamics, things that are just fundamentally beyond the reach of traditional empirical methods.
That's a huge potential impact. But there are ethical considerations too, right?
Oh, absolutely crucial. The paper is clear on this. While the potential is immense, LLM sims need rigorous verification. They need to be used ethically. There shouldn't be seen as a wholesale replacement for engaging with real human experience and perspectives. And we have to be mindful of potential misuse, things like generating sophisticated propaganda or creating manipulative bots for social engineering. Those are real risks we need to guard against.
Unnecessary caution. Now, this field is exciting, but it's not without its critics, right?
Yeah.
What are some of the counter-arguments or maybe alternative perspectives the paper acknowledges?
Yeah, it's important to represent those too, and the paper does a good job. It notes that some very prominent researchers have expressed pretty significant doubts. You have the famous stochastic parrots argument, suggesting LLMs are just sophisticated pattern mimics without real understanding.
Right, Bender et al.
And others, like Chomsky, have argued they have fundamental, ineradicable defects that prevent them from achieving true human-like intelligence or reliable social simulation. These critiques basically argue there's a hard ceiling on what LLMs can achieve, especially when it comes to capturing the nuances of human cognition and social interaction.
So, deep skepticism about whether they can ever be truly human-like simulators. How do the authors of this paper respond to those kinds of fundamental critiques?
They acknowledge the arguments, but their core response is essentially empirical. They argue that these theoretical debates can only take us so far. Ultimately, the question of whether LLM social simulations are viable, how far they can go, has to be answered through rigorous testing, through evidence. Let the data speak, basically. Don't dismiss the potential based solely on theoretical arguments before we've fully explored what these systems can actually do.
A call for empirical validation, then. Well, this has been a really fascinating deep dive. It's so clear that LLM social simulations are much more than just a passing fad. This feels like a genuinely promising research method that really could reshape how we study and understand human behavior and how we apply AI.
I agree, it's a dynamic field. And while those challenges, diversity, bias, sycophancy, alienness generalization, they are significant, absolutely. But the research community is incredibly active, developing really clever solutions, from context-rich prompting and advanced fine-tuning like with Laura to digging into mechanistic interpretability. It's genuinely exciting to watch unfold.
It really underscores that these incredibly powerful models still need our scientific diligence, our critical thinking, our ethical frameworks to guide them towards truly beneficial outcomes. We're not just building tools, we're potentially building new ways to understand ourselves.
Which leads to a final thought, maybe something for you, the listener, to ponder. As these LLM capabilities keep accelerating and as we get better at overcoming these challenges, what completely new insights might become possible? What previously unimaginable understanding of complex human societies, of individual decisions, could these digital minds unlock insights that maybe were simply impossible to grasp through traditional methods alone? What fundamental truths about ourselves are waiting to be uncovered with the help of AI?